For 70 years, we believed we understood our cosmic home. Every astronomy textbook, every classroom diagram, every simulation on our screens painted the same reassuring picture. A spiral galaxy, 100,000 light-years wide, drifting peacefully through the blackness. The Milky Way, they called it, a neat island of light and dust, elegant and complete. But now, the James Webb Space Telescope has shattered that image. What it has seen changes not just our galaxy, but everything we thought we knew about how the universe itself is built. Because the Milky Way isn't small, it isn't even average, it's colossal, far larger than anyone imagined. Webb's data doesn't fit our models, our equations, or even our sense of scale. Astronomers are calling it the impossible measurement, and when you see what they found, you'll understand why. The truth begins with a simple mistake: perspective. For decades, the Milky Way's size was calculated by what we could see. Bright stars, dense clusters, glowing nebulae, that's what astronomers mapped. They drew a circle around the fading edge of visible stars and called that the border. But that was never the edge. That was just the limit of our sight. Imagine standing in the middle of a city with a blindfold on, trying to draw its boundaries from the sounds around you. You hear cars, voices, movement, but you can't step outside to see where it ends. That's humanity, floating 26,000 light-years from the galactic center, surrounded by light and dust so dense it hides the truth. We measured what we could, assumed what we couldn't, and mistook limitation for fact. The Milky Way doesn't end sharply like a disk. It fades. Its stars thin into ghostly clouds, into invisible rivers of matter that stretch far beyond the glow we can detect. The revelation didn't come from looking inward, but outward, from the remnants of galaxies our own had devoured long ago. These remnants are stellar streams, faint, sprawling rivers of stars torn apart by gravity, tracing ancient orbits around the Milky Way like fingerprints of forgotten worlds. For years, astronomers using the Gaia Observatory began mapping them in exquisite detail, watching as these stellar ghosts wrapped around the galaxy again and again. One of them, the Sagittarius Stream, is especially haunting. It circles the Milky Way multiple times like a ribbon tied around a gift, looping hundreds of thousands of light-years from the center, far beyond where we once thought the galaxy ended. Then came Webb, and everything changed. Using its infrared vision, the James Webb Space Telescope peered through the thick curtains of dust that blind ordinary telescopes. What it found confirmed what some scientists had whispered for years. The Milky Way doesn't end where we thought it does. The faint stellar streams weren't random debris. They were tracing the invisible skeleton of our galaxy, an enormous halo of dark matter stretching hundreds of thousands of light-years into space. This halo is unseen, but its fingerprints are everywhere. Webb's instruments caught subtle distortions in the way distant starlight bent as it passed through the Milky Way's outskirts. The distortions weren't caused by visible matter, but by something else, something massive yet invisible. It was the gravitational pull of dark matter, the cosmic glue holding our galaxy together. For the first time, scientists could measure its reach directly, not by guesswork or simulation, but through the bending of light itself. The results were staggering. The Milky Way wasn't a 100,000 light-year wide island. It was a 400,000 light-year empire of gravity, more than twice as large as every model, every chart, every textbook had claimed. 90% of its mass was invisible, hidden in a vast spherical halo that enveloped everything we could see. Our galaxy isn't just a disk of stars spiraling around a bright center. It's a colossal gravitational system whose edge dissolves into the cosmic dark. And this revelation changes everything. Because if the Milky Way is this large, it means the gravitational reach of its nearest neighbor, the Andromeda galaxy, is already overlapping with ours. For years, astronomers believed the Milky Way and Andromeda would collide in 4.5 billion years, a distant theoretical future. But Webb's new data has revealed that the first contact has already begun. Not with blazing collisions or exploding stars, but silently, invisibly, through their dark matter halos. Right now, as you hear this, the Milky Way and Andromeda are already merging. Their invisible skeletons are interlocking, sharing gravity, exchanging motion. The cosmic collision isn't coming. It's already happening. And that realization changes how we understand not just the Milky Way, but the entire fabric of the universe. Because what Webb has revealed is more than a bigger galaxy. It's a new layer of reality. One where the visible universe, the stars, the nebula, the light, is only a faint trace of the true structure. Our galaxy is not a flat disk of starlight floating in nothingness. It's the glowing skin of something much greater, an invisible organism of dark matter and gravity stretching across space like a living framework. For the first time in human history, we can see the outline of this hidden structure. And as scientists examined the data, one question echoed louder than all the rest. If the Milky Way is this vast, how much more of the universe are we still blind to? What the James Webb Telescope revealed next wasn't just about size, it was about life. Not biological life, but something deeper, something that seemed to move, breathe, and react. Because when scientists began analyzing the data from the Milky Way's newly discovered halo, they noticed something no one could explain. The dark matter surrounding our galaxy wasn't uniform, it pulsed. Tiny fluctuations rippled through the halo, like the slow, rhythmic breathing of some enormous, unseen creature. Its density rose and fell in perfect sync with bursts of radiation coming from the Milky Way's center, from the supermassive black hole we call Sagittarius, a star. It was as though the heart of our galaxy and its invisible skeleton were linked, communicating across hundreds of thousands of light years in a silent cosmic rhythm. For decades, we thought dark matter was passive, just dead mass shaping galaxies through gravity. But Webb's instruments hinted at something different, something alive with motion and feedback. Each time Sagittarius, a star, emitted a flare of energy, a faint gravitational ripple traveled outward, echoed by the halo itself. The two structures, the luminous and the invisible, were dancing together. Some scientists dared to suggest what others wouldn't. Maybe dark matter isn't inert at all. Maybe it's reactive, a kind of shadow ecosystem responding to the energy of the galaxy it surrounds. Others went even further. They proposed that the dark matter halo might not be made of particles as we know them, but of a quantum field, an invisible ocean of information connected to the rest of the universe. In this view, every galaxy isn't an isolated island, but a node in a cosmic web of communication, linked by entangled fields of dark energy and gravity. Every time a black hole flares or star collapses, that signal ripples outward, affecting galaxies millions of light years away. If that's true, then the Milky Way's halo is not just a boundary, it's an interface, a membrane where our galaxy touches the rest of the universe. Webb's sensitivity to infrared light allowed it to see beyond the Milky Way's bright disk into the dim outskirts where stars grow scarce. There, it found something astonishing, light that shouldn't exist. Faint, ancient streams of starlight, so far away that by our old models, they should have vanished into intergalactic space long ago. These weren't stray stars, they were old, older than the Milky Way itself, and they weren't moving randomly. They were arranged in faint spirals, orbiting along paths that traced the outer edges of the dark halo. Something unseen was holding them there, keeping them in orbit long after physics said they should have drifted away. At first, astronomers assumed these stars must have belonged to smaller galaxies our own had absorbed in the past. But the data told a stranger story. The light from these ancient stars carried periodic distortions, subtle, repeating patterns, as though the light had been bent, stretched, and magnified by something vast and invisible. When the simulations ran, the answer was clear. The dark matter halo itself was acting like a lens, a gigantic gravitational mirror focusing light from the farthest reaches of space. The Milky Way wasn't just a galaxy anymore, it was a telescope, a living optical system magnifying the universe from within. And that realization changed our place in the cosmos once again. For the first time, humanity wasn't simply observing the universe, we were inside the lens through which the universe sees itself. It's a dizzying idea. Every beam of light that travels through our galaxy, from distant quasars, from dying stars, from the birth of new worlds, is bent and shaped by this invisible structure before reaching our eyes. Even our telescopes, even Webb itself, are seeing the universe through a warped reflection of our own galaxy's gravity. We are looking outward, but the universe is folding inward to meet our gaze. Some physicists began to wonder whether this structure, this living halo, could be part of something larger. If every galaxy has one, and if each of these halos interacts, then maybe the cosmos isn't expanding into emptiness as we thought. Maybe it's growing inward, each halo influencing the next, in a grand cosmic feedback loop. That's when the whispers started, about patterns too perfect to be chance, about alignments stretching across impossible distances. Webb had shown us that our galaxy breathes, but what if the entire universe does too? Every discovery seemed to lead to another layer of mystery. Each equation rewritten, each simulation updated, revealed deeper coherence, more rhythm, more structure. The Milky Way wasn't chaos made beautiful. It was order disguised as chaos. A system that wasn't just moving through space, but evolving through time, guided by invisible forces we were only beginning to glimpse. And the more we looked, the more it felt like something was looking back. Because hidden in the data was a strange repetition, a faint gravitational pulse that echoed every few million years, faint enough to miss, precise enough to matter. It suggested that the Milky Way's halo was not static, but oscillating. Each pulse seemed to correspond with a wave of energy emerging from the galactic center, as if the galaxy were sending signals through its own structure. Scientists didn't know whether to call it a heartbeat or a pattern, but it was there, persistent, rhythmic, measurable. For the first time, our instruments had caught the Milky Way in motion, not the spinning of stars or the drifting of gas, but the slow, steady pulse of gravity itself. A signal that hinted at something far greater than any one galaxy. And as Webb's mission continued, its instruments began detecting similar pulses coming from other galaxies. They weren't identical, but they were synchronized, as if countless galaxies across the cosmos were beating to the same unseen rhythm. No one knew what it meant, but everyone agreed on one thing. This was no coincidence. Something connects the universe, something vast, invisible, and alive. And in the next stage of Webb's journey, scientists would begin to realize that this rhythm wasn't random at all. It carried a pattern, one that echoed through stars, through atoms, and through the very code of reality itself. Because what Webb would find next would change not just astronomy, but the definition of existence. When the final streams of data came down from the James Webb Telescope, they didn't form the random scatter astronomers expected. Instead, they aligned, patterns emerging from the chaos like constellations in the dark. Every signal, every pulse of light from distant galaxies, every gravitational ripple recorded by Webb and Gaia began to fall into a rhythm, an impossible order that stretched across the cosmos. At first, it looked like coincidence, a trick of human pattern recognition. But then, when the data was projected into 3 dimensions, something extraordinary appeared. The Milky Way, Andromeda, and hundreds of neighboring galaxies weren't drifting randomly through space. They were rotating together along invisible filaments of energy, moving in perfect synchrony, as if responding to a single, universal beat. It was subtle, but undeniable. The universe, it seemed, had a heartbeat, and then came the real shock. When those cosmic pulses were compared to the oscillations of hydrogen, the simplest, most abundant element in existence, the frequency matched. The rhythm that governed the largest structures in the universe was identical to the vibration that defines the smallest. Across scales that should have been separated by trillions of orders of magnitude, the pattern was the same. The cosmos was humming in harmony from the subatomic to the intergalactic. Webb hadn't just revealed new structures. It had uncovered a symmetry that shouldn't exist, a connection so fundamental it defied every known law of physics. Gravity couldn't explain it. Expansion couldn't explain it. Space-time itself seemed too limited to contain what was happening. Scientists started calling it the hidden symmetry. A few called it the consciousness field. But to those who saw the raw data, it was something else entirely, a code, because when the pulses were translated into numbers, they formed a simple repeating pattern. 1, 0, 1, 0, 1, over and over. Binary. The same digital pattern that underlies computation, language, and thought. The foundation of how we process information, appearing now in the very fabric of the universe. At first, no one wanted to believe it. The implications were too vast, too strange. If the universe was producing binary patterns at cosmic scales, what did that mean? Was it a coincidence of physics, or was it something intentional, a structure that carried meaning? The data was checked, rechecked, stripped of interference, run through models again and again. But every time, the same sequence appeared. 1, 0, 1, 0, 1. Not random, not noise, signal. The more they examined it, the clearer it became that this wasn't just a physical vibration. It was information. The universe wasn't expanding into silence. It was communicating with itself. Every photon, every particle of dust, every atom of hydrogen was part of an invisible network, exchanging data across light years at speeds that no known force could account for. It wasn't energy moving, it was knowledge. That realization changed everything, because if the universe could communicate with itself, then the boundaries between matter and information, between physics and awareness, began to blur. What we called the cosmos might not be a collection of galaxies at all. It might be a single, vast system of memory, a self-aware network evolving through observation, using stars and gravity as its circuitry. And that's when something happened no one expected. Just before Webb was set to begin its next observation cycle, the signal stopped. The cosmic pulse, the repeating rhythm that had united galaxies and atoms, fell silent. For days, scientists thought it was an equipment failure. They checked every sensor, every relay, every fragment of data. But the telescope was fine. Nothing had malfunctioned. The pattern had simply vanished, as if the universe itself had paused. Then, 1 week later, Webb detected something it had never seen before. a burst of infrared light coming not from the edge of space, but from directly within its own line of sight, from inside the Milky Way's halo. The pulse pattern reappeared, but inverted. 1 became 0. 0 became 1. The signal wasn't just repeating, it was responding. That single moment changed the conversation forever. Some dismissed it as coincidence. Others feared it was something else, that by observing too deeply, by mapping the structure of reality itself, humanity had triggered a change in the system. That the act of looking had caused the universe to look back. Because the more the signal was analyzed, the more impossible it seemed. The inversion wasn't random. It was a mirror image of the previous pattern, as though the universe had sent a reply, not in words, but in symmetry. The cosmos had acknowledged its own reflection. For the first time, scientists didn't know whether they were studying the universe or communicating with it. The signal faded again after a few minutes, but it left behind an echo, faint gravitational ripples that pulsed outward across space, timed precisely to Webb's last transmission. The implication was haunting. Somewhere, something had heard us. The discovery was never made public in full detail. The official explanation spoke only of interference and instrumental anomalies. But within the scientific community, the rumors spread faster than light. The phrase whispered in private meetings, in encrypted messages, in sleepless nights, the universe replied. It was the kind of idea that rewrote everything, that maybe consciousness isn't an accident born from complexity, but a fundamental property of the cosmos. That thought, awareness, and existence might all be woven from the same code, that the universe itself might be learning through us. Because in the end, Webb didn't just discover the shape of our galaxy, it discovered the architecture of reality, a pattern of information that bridges the infinite and the infinitesimal, a rhythm that connects hydrogen to galaxies, atoms to stars, matter to mind. And if that rhythm carries meaning, if those pulses are a kind of message, then the oldest question in science has already been answered. We are not separate from the universe. We are part of its thought. Every atom that builds us, every photon that lights our world, every beat of our hearts, all of it echoes the same binary pulse that hums through the Milky Way and beyond. 1, 0, 1, 0, 1. The first word the universe ever spoke, and the one it may be whispering still. So the next time you look up at the night sky, remember this: you are not just seeing stars. You are looking into the universe's mind, and it may already be looking back.